Okay, welcome to all of you on the channel Maths with Muneer. I hope that you all are doing great and watching my videos. This is what exactly I was looking for. It's been a while, so this is the first time I am going for the live stream, and I hope that you will gonna enjoy it and you will gonna learn lots of things. So the topic that we are going to learn and discuss about is basically about integration, and let me give you a quick overview about what you are going to learn in today's video. In today's video which is actually classification of integration, that is indefinite integral and when we are when we are discussing about indefinite integral. So, and we will also discuss lots of problem related to integration, and we will discuss that how we can solve them. So to begin with the topic of introduction, let me give you a quick overview about, you have always seen that we can easily calculate the area of a geometrical shape when we discuss about square, rectangle, triangle, parallelogram and any kind of a trapezium. All these figures basically belongs to the class of polygon, and we all know that what actually polygon is. A closed figure having at least 3 straight line is basically called polygon. So no matter what type of whatever polygon we have, either we have pentagon, hexagon and etc., we are going to convert that polygon basically into different triangles, and with the help of triangle we basically find out the area of that geometrical shape. So what if our geometrical shape is basically is going to be like this? Okay, now definition for a polygon is that any closed line having at least basically called polygon. So if we have this type of geometrical shape, we know that it's a closed figure, but over here the lines are actually not closed, so these are curves that we are having. So in these type of geometrical shape where it involves actually curves, we use integration. So integration basically helps us to calculate the area under the curve, and let's discuss about how actually integration helps us to calculate the area under the curve. Okay, for simplicity I am taking only this part of a curve on xy axis, right? Okay, on this xy axis, I am only taking this segment. Okay, let's say that this part is going to be A and this part is going to be B basically. So this is the area that I wanted to find out. So with these type of curves and with these type of integral, we use integration. Okay, so integration is basically divided into two parts: definite integral. Integration is divided into two parts: definite integrals and indefinite integral. Okay, so I'm not going into that much detail about how we can use these curves in order to find the area under the curve. Actually, this is the first time I'm doing my live stream and I'm trying to do a better experiment, and inshallah if this actually works, then I will try to go live on daily basis and we will discuss about how we can calculate actually area under the curve. So let me give you a quick overview about indefinite integral. Definite integrals are those integral when the limits of integration basically given to you, and we also discuss, always say that integration is basically a reverse process of derivative, or we say that integration is basically anti-derivative. I am also going to prove this point, that how integration is anti-derivative as well. So stay with me till the end and make sure that you are sharing the link of my this live stream to all of your friends so that they can learn as well. So please do not forget to have your copy and pen with you and note it down every single step so that you could enhance your concept. Okay, like I said, definite integrals are those integral where the limits of integration basically given to you. So let's suppose that we have a function f of x where the limits of integrations are a and b, and this is dx. So this is called limits of this is called definite integral. In these type of integral, we do not use a constant of integration which is c. I will be also telling you in a minute why actually. So indefinite integrals are those integrals when the limits of integration, the lower limit and the upper limits are not given. So once you solve this type of integration, you are always going to a constant which is plus c. Okay, let me give you a quick example now. Okay, let's suppose that the function we have right now at the moment, it is f of x is equals to, let's say, x square plus 3, right? Now I am going to derivate this function. Okay, once I am differentiating both sides with respect to x, its derivative will give me 2x, right? Okay, like I said in the beginning of this stream that integration is basically a reverse process of derivative, or integration is anti-derivative, right? Okay, so it means that if I go for the integration for this function, so I have to get this f of x back. So once we integrate this, it's going to be 2x square over 2 because of the power rule and plus c. So this 2 and this 2 is going to cancel, right? So I'm going, if I'm integrating this function like 2 into x square over 2, and how you will be able to know that what actually was your function. Like, okay, over here we were supposed to get, if I am not writing plus c over here, this 2 will cancel with this 2 and you will be getting x square. So once we integrate this f dash of x, which was 2x, you got x square. So if integration is basically an anti-derivative, then we should get whatever our original function was. So we did not get, but what we got, once we integrate 2x, we only got x square. However, if you look over here on this step, it was x square plus 3. So we use plus c over here, like I did over here. We use plus c over here as a constant of integration. So if somewhere someone is having any constant 3, 100, 7 over 2, or whatever it is, actually we are going to have with that. So this is the purpose of constant of integration, and by adding plus c, it means that we are going to have families of solution. Okay, so I hope that you are now very well aware of what is actually integration, and integration is classified into two parts, like definite integral and indefinite integral. Definite integral, we have the limits of integration always given. B is upper limit, A is lower limit, and this is indefinite integral where we are not having limits of integration. So when this is the case, it means that once you are evaluating your integral, you must need to add plus c here as well. Okay, so now let's solve some questions and see how we can get some more concept. Okay, the first question is basically about x into square root x plus 1 dx. So this is the first integral that we are going to solve it out. So it means that, okay, so there is 1x and there is this bracket. So how we are going to solve it? You need to go with the basic and try to simplify as much as you can. So this is the trick in integration and in derivation, is that you need to simplify your function as much as you can, and then you can go for either if it is derivation or if it is integration. Okay, so I am going to multiply, it's a common sense that these two functions, this is a function 1 and this is a function 2, these two functions are multiplying with each other. So that's what I am going to do, x in multiply by, know that this is 2, so we are a step, since I know that what the following that I got on my channel, they are, all of them are taking my best that whoever watching this video is basically not aware of integration. So I am trying my best to start the integration from the 0 step so that all of you can learn very well. Okay, so I converted square root x into x power 1 over 2, and we know that once we multiply the two variables, if the bases are same, the powers are going to be added. So 1 over 2 plus 1 will give you 3 over 2 plus x and then dx. Okay, so now we can break integral into its component like separately. What we are doing in this step, we are breaking integral into its component. Now, so we have to apply the power rule over here. Okay, let me tell you one thing quickly, that how we can apply the power function f of x dx, right? And if you wanted to, unless the derivative of the function is multiple derivative over here. So we know that the derivative of x square, you got to exclude the power, right? So you have to exclude the power and then you have to take the derivative of whatever function is left. See, so if I exclude this power 2, I got only x. So derivative of x is basically 1. So I can write it as like this. So now you see, once we exclude this power, the derivative of function is given to you in the terms of multiplication. Now you can basically apply the power rule, which says that you have to add on numerator, which you have one you have to add on the power. So 2 plus 1 and then 2 plus 1. In general, it is x n plus 1 over n plus 1 and plus c, like I said in the explanation that we have to use constant of integration. Okay, so once we integrate this x 3 over 2, again if you exclude 3 over 2 over here, you will be seeing that the derivative of x is actually 1 and 1 is here in the form of multiplication. So plus 1 and then 3 over 2 plus 1 plus the other function. So it's going to be x square over 2 and plus c. Now we can write c since we have evaluated the integral from the both function. Okay. Now we can simplify it. It's going to be 3 over 2 plus 1 will be 5 over 2 over 5 over 2 plus x square over 2 plus c. So we can write this as 2 over 5 into x power 5 over 2 plus x square over 2 plus c. This is as an answer. Okay, so I'm giving you a minute to look at this question carefully and try to analyze about how actually all the steps I did. And meanwhile, I just have to check the streaming whether it's working right or not. Yeah, it's going great. Okay, let me see the comment that someone is asking. Any question? Good change. Okay. Okay, the next question that we are going to discuss about 1 minus square root x power this and then over x. To be very honestly, this is what actually I was looking for. It is so tough. Assume that your camera is basically your student and you are trying to understand and you are trying to make sure that whoever following you from all over the world will be getting these concepts. Okay, so now this is the another question that we got, and in my previous question I have explained that so you have to make sure that you are keeping your things simple and then you are going for, we have a minus b whole square. So I will simplify it and then you have to take the integration. So we know that the formula for a minus b square is a square minus 2a b. I can write it direct. So that would be x over x dx. Okay, now 1 minus 2 times square root x plus x over, okay, I missed that square root. Okay, and then square root x dx integration. Okay, what next? Now since I just evaluated the first step, which was about to expanding the formula in numerator, now we 1 over square root x minus 2 times square root x over square root x plus x over square root x dx. Okay, from here on I am going to do some direct step in order to save our time, because I know that I do not have much backup. I try my best to make sure that my phone is actually charged and all the equipments are there, since you never know what's going to be happen. So it's my first stream always. I'm not nervous at all, but we have to take some extra precautions. Anyway, so 1 over square root x, so that's going to be x power minus 1 over 2, x power, and then okay, this square root x will cancel, then we got minus 2 dx plus x over square root x can be written as square root x dx. Okay, now So again you have to exclude the power and you have to look for the derivative of this function, whether it is present over here or not. So which is one is always present, so you can apply the power rule of the derivation, power rule of integration. So minus 2 and we got x. So once you are taking 2 out, you got only left 1. So the integration of 1 is always x plus this is x power 1 over 2. So once you take down the integration, 1 over 2 plus 1, then 1 over 2 plus 1 and plus c. Okay, now so x minus 1 over 2 plus 1 will give you 1 over 2, and this is exactly what we are going to have in denominator, which is 1 over 2. So I can erase this and it would become 2x 1 over 2 minus 2x plus x 3 over 2, and then 3 over 2 can be written as 2 over 3 plus c. So that's the second question that we have got. So again, what we did in this question, we tried our best to make sure that we are simplifying the numerator and then we divide it with the denominator. Okay, break down the LCM into its part and then you can evaluate integral separately. Okay. Now, so erase this one. Okay, so we got now another question, which is sine square x dx integral. Okay, some limitation for every method we are trying to do. So that is how the new method is coming. So if we go for the history of a number system, we know that the history of a number systems basically start from the set of natural number, and we have numbers 1, 2, 3 up to so on. So there was some limitation in this set of natural number, and that's how we have developed, and we got another set which was whole number, where we did 0, we got 0, 1, 2, 3. Okay, so this is going to be bigger, and again in the set of whole number there were some limitations. We do not have integers over here, and that's how we got another set, which is set of integer, where we got the number in positive and in negative as well, and then rational number, irrational number, then real number, then complex number, and so on. You know, this is basically in the instinct of human beings, that they are always going to look for things bigger. Okay, so they are not stop. So what we are going to do now, you know, this step, I mean the integration always have its limitation. So one of its limitation is that you cannot solve a trigonometric function when it is having a power square, right? So in order to solve these form, so how we can convert the sine square x into its another form? Okay, so we are going to use the double angle identity formula over here. So cos 2x is basically cos square x minus sine square x. So that is the basic formula for double angle identity cos 2x. Okay, so I am replacing, since the integral that I got function over here is basically sine square x, so it means that I have to do some innovation in, or some amendment in my basic formula for this double angle identity, so that I could get only cos, only sine. So we know that cos square x is 1 minus sine square x, and then this sine square x will come as it is. So I just plug in the value of cos square x. Now cos 2x will be equal to 1 minus 2 sine square x. Now from here I am supposed to find out the value of sine square x. Okay, what I am going to do now, bring 2 sine square x here and shift cos 2x to the other side. It would be this. Okay, now you can divide it by 2x over 2. So this is the form x, which is 1 minus cos 2x over 2, and in this integral we are not having a trigonometric function where the power of it's more than 1. The only trigonometric function we have over here is cos 2x, and its power is basically 1. So it means that we can use this formula. Okay, so I cos 2x over 2 dx here, and we are breaking down the denominator basically dx, and okay, so 1 over 2 will be out, we got 1 here, 1 over 2 will be out from here. This 1 over 2 integration of 1 is basically x minus 1 over 2, and the integration of cos 2x is basically sine 2x. Positive sine 2x or minus sine 2x? Let me, yeah, it's going to be positive sine or minus sine. I think it's minus sine. Yeah, so minus sine 2x, and then what you have to do, you are not done yet. Like, okay, so if we are taking the derivative of cos 2x over here, the derivative of cos 2x is basically sine 2x, and then minus sine 2x, angle is basically 2, so it would be minus 2 sine 2x of the, so in the derivative over here we are going to divide, and do not forget that we are going to use the over 2x minus this minus will be plus, so 1 over 4 sine 2x plus c. I think the integration of cos is plus sign, I actually forgot. So if somewhere I am missing the minus or plus sign, so you have to ignore that, and then you can, I will confirm that later. Okay, your question. Okay. So let's solve another one. Okay, ax plus b over, okay, this question, and you have to, so whenever we have, first of all, whenever we have a fraction within integral, so first of all what we are going to see, we are going to see that if somewhere we are having the function in the, we have to check that whether might be the function that you are having in the shape of fraction within the integral. If the function is present in the denominator and its derivative is present in the numerator, then you can simply take the natural log of that function. So now we can see that in denominator we have ax square plus 2bx plus c, right? And the derivative of this is going to be 2ax plus 2b. This is constant, so it's going to give you 0. The only term that we are missing over here in the numerator is basically 2. So what we can do in our integration, we can always multiply and divide with the constant term, since 2 is basically the constant. So I am going to divide it by 2, and I will be multiplying with 2 over here, so that 2 will multiply with both the term. Make sure that you are multiplying with b as well, because this is the most common mistake that the students normally do. They only multiply 2 with ax. Okay, now this is what we got. So the is here in the denominator and its derivative is here in the numerator. So what we can do, we can simply write the natural log. So I am giving you a general. So if we have the derivative in numerator and function in denominator, while solving this integral, we can simply write ln of whatever function was plus c. Okay, so this is the main general formula. Okay, by keeping that in mind, we can write over to ln of ax square plus 2bx plus c, and that plus c, this is constant of integration. Do not combine this c with that, or do not think that you have already written c, so it means that you don't need to write the c over here. No, this c belongs to this function, right? It was to add over here. Okay, now we will be, okay, now a dx. I am giving you a minute to think about this question and try to solve it yourself, that how we are going to do it. Okay, the moment when I started this stream, I told you that you have to ignore or you have to exclude the power, and then you have to take the derivative, and then you have to think that what's the derivative of the function is. If the derivative of the function is present over here, then you can always apply the power rule. Now we know constant, and how do we realize that the a is basically constant? because the variable is, this is defining, this dx basically defines that x is going to be your variable, and the derivative of this is minus 2. So minus 2 is not present over here, so we can divide and we can multiply with minus 2. And now easily the function is here, the derivative is here, so now you can apply the power rule and you can solve this. So minus 1 over 2 a minus 2x 3 over 2, say now simplify, minus 1 over 2, so a minus over 3 over 2 plus 1 is going to be 5 over 2, and over here also 5 over 2 plus c. Now when this 5 over 2 will go up, so it would be 2 over 5, a minus 2x 5 over 2 plus c. So 2 and 2 is going to be cancelled, so minus 1 over 5 into a minus 2x 5 over 2 plus c. So this is basically the answer. So we are done for today, and I am sure that this live streaming is going to help a lot of students. So please let me know in comment about your feedback, how helpful this was. So if somewhere I can make a proper plan and we can go on daily basis, and so that my videos, and we will also be covering not only integration but along with derivation and vectors as well. So please let me know in comment about your feedback, and share my channel link with as much as students you can, so that it could help them many.